Okay, thank you so much. Well, good afternoon, ladies and gentlemen. Thank you very much for joining what I think will be a timely and very well-informed panel around what new technologies can secure energy for the next century. We're very much, I think, at an inflection point, halfway through this decade to 2030, where our progress towards so many climate and development and national goals will be kind of marked. On many fronts, we've seen great progress. Clean energy is entering the global energy system at an unprecedented rate, including more than 560 gigawatts of new renewable capacity in 2023 alone. We are now approaching 2 trillion of annual investment in clean energy, almost the double amount that is going into fossil fuels. The global policy environment at the moment remains pretty conducive to seeing a further acceleration as well. We may get into a little bit how that could change later on. However, we're still facing many challenges to ensure both that this progress is continued and accelerated, that it has the real impact around the climate that we need it to have, and it has a broader access to the whole population. Greenhouse gas emissions hit a record high in 2023, and there are over 1 billion people in energy poverty currently, and 675 million that don't have access to any electricity. And as we've seen the impact from Ukraine and other geopolitical issues sort of ease in the energy system, we're now seeing other challenges through trade. There are more than 200 restrictive trade restrictions have been brought in under clean energy technology around the world. And as we look around the world, many issues around permitting time, grid expansion are acting as a significant brake. And in many emerging markets outside of China, investment into low-carbon technologies still remains at sort of 10 to 15% of total capacity. We've got a fantastic panel to dig deeper into these issues. If I can sort of introduce from my left to right, I've got Anthony Baker, the CEO of SatVu. SatVu, can we say that right? Yeah, fantastic. Dr. Jennifer Holmgren, the CEO and chair of LanzaTech. Ricardo Falu, the COO and president of New Energy Technologies at AES Corporation, and Mohammed AlBalaihed, the head of energy and utilities at the PIF. Ricardo, if I can start with you, one of the topics that we heard this morning, and certainly if you've been involved in any of the discussions around energy systems, particularly in the US over the last 3 months, is AI. And the title of the panel is about what's going to happen over the next sort of century, but actually there's a real near-term potential headwind, which is the insatiable demand that we're seeing from AI and data centers. How do you think, and how is AIS thinking about AI both as a potential headwind in terms of what it needs to be overcome to meet that demand, but also a potential tailwind for catalyzing new technologies?
Sure. No, thank you so much, Daniel, and good afternoon, everyone. It's a great pleasure to be here with you all. So, there is no doubt that artificial intelligence is the technological revolution of our era. And for us at AES, of course, is a unique opportunity, not only because of the massive demand it brings for power, but also because it brings technology that we can apply and optimize the electric grid and look for ways to accelerate the advancements of several technologies. Just to put the demand growth into perspective, in the US, first of all, AES is the largest provider of energy solution to Microsoft, Google, Amazon. And just in the US, these big tech companies, the demand of electricity, the demand of power is expected to grow from now to 2030 by 450 terawatt-hours a year. That equals to the consumption today of France. So how we address as a company that humongous or massive demand is critical so as not to worsen the humankind's global emissions and therefore the global, we further contribute to the global warming. I think, as a company, what we're seeing is the technology that is going to win, for sure, at least for the next 10 or 15 years, will be solar, will be wind, of course, combining with batteries, energy storage. AES is a leader, through Fluence, We have deployed the first batteries back in 2009 in Chile. And since then, you can see the application of batteries everywhere. However, this is for 4-5 hour duration, so it helps you address some of the intraday needs, but does not provide the capacity that you need in the system. Capacity, I define it as the ability to produce electricity 24 hours a day, 365 days a year. That wind, solar, and even with batteries today cannot do. And therefore, you need to have that capacity in many markets where you have nuclear, where you have hydro, some geothermal can be carbon-free, but in most of the markets, you rely on thermal generation. So if you ask me, Ricardo, how you see the US attending such a huge demand, clearly in the next 10 years will not be nuclear. It's going to be more gas coming into the grid, to really accommodate the humongous penetration of renewable. And don't see gas as gas against renewable, but gas as a way to accommodate much more renewable. I'll leave it there. There are many bottlenecks, but I just want to make sure that the rest of the panel do have the opportunity to comment.
No, thank you. I think you've teed that up quite well in terms of the near term, both headwinds and potentially some solutions there. I mean, Jennifer, maybe if I can come to you. I mean, when Ricardo talks about gas, one of the things that goes through my head is sort of carbon capture then, and how we think about the difference between gas and abated gas. And I wonder if you could just touch on that. And actually, if we look at say what the IEA it projects in its net zero scenario, it sort of says that 35% of the emission reductions come from technologies that need to be scaled up. I mean, what do you see as being the real critical impediments to scaling up the next wave of technologies around carbon capture, but also into other sources of energy or storage?
Well, first of all, let's just take a step back and talk about what it takes to scale a brand new technology, something that's disruptive. Solar, EVs, it takes 30 to 40 years to get to a point where you're deploying your nth plant and getting down the cost curve, right? And so you've got to get to the first commercial plant, then you've got to get to the next few that drive it down the cost curve until you get to a cost parity or advantage scenario. The problem is that as you scale, it's very difficult not to be the first of a kind. Everybody wants to be first to be second. And so what that means is getting the financing for the first ones is very, very difficult. We are starting to see movement from financing early stage R&D in governments through financing of first commercial plants. The Innovation Fund in Europe, the Department of Energy in the United States is now financing commercial deployment. So to me, to scale, the first and most important thing is finding sources of capital that allow you to access capital for the first of its kind when you're building a commercial scale. So this will be true not just of solar EVs, but it will also be true of carbon capture technologies. And the only additional comment I would make is that we need to guard against the negativity. Because what ends up happening is in those 30, 40 years it took solar to get to where it is today, even 10 years ago, people were laughing that solar would never scale, right? And so that's what we have today is everybody wants to talk about sequestration or utilization, which is what we do. And everybody laughs at the fact that it doesn't make economic sense. And when is it going to be ready? Well, you build that big CCS project. If somebody doesn't build the first one and the second one and the third one, they will never make sense. And so if you really want to deploy new technology, everybody needs to have the patience and to stick with it until everything gets to scale. And that lack of patience is not helpful.
And so, Anthony, I mean, turning to you then, so there's a sort of mixed picture we're hearing a little bit from Ricardo, and a lot of demand coming from AI, but still some challenges in scaling sort of low carbon alternatives or complementary technologies to renewables. nonetheless, we are going to see this trend of electrifying everything. I mean, how do you see these things working out, and how can we help sort of heavy emitting industries start to electrify and start going down this curve, not just in the power sector?
So I think there's two parts to the equation. One, resilience of the supply, but also efficiency of the use. So we have technology. We've launched a satellite into space with a thermal camera, which brings the activity layer to any insights. So whereas you're looking at Google Earth, you see a static picture. With our activity layer, you can see which plants are on and which plants are off, or where we're wasting energy, or where energy isn't being produced. So, for example, in northern climes, when it gets cold in the winter, we can identify which buildings should be retrofitted. If we save energy, we don't need to build so many wind farms, for example. In hotter climes, we can identify the causes of urban heat. So we all know the city's hotter than the rural areas, but what's causing it? We can look at a very granular level of which buildings are causing the heat excess, and we can then point to mitigation techniques to be able to solve that. So having this single source of truth and a worldwide view, we can help with the resilience of the energy supply.
So, Mohammed, can I turn to you then? So, I mean, we've got quite a high degree of uncertainty around how demand may grow exponentially, the types of ways that that demand may be met in terms of traditional hydrocarbon, gas, Ricardo mentioned, new technologies. I mean, can I bring it to the kingdom now where we're sitting today? And just, I mean, for the export of energy in the future, how do you think about the export of electrons versus molecular? And particularly from a sort of dense energy carrier. How do you see that changing over the coming years?
Thank you. I mean, to start off with, when it comes to the kingdom was already a reliable supplier of energy for the past 80 years. And what we see today is that economies are really transitioning to net zero emission technologies. And for Saudi, this represents a huge opportunity. And it's also an ambition that we have. And of course, why do we have that ambition? Because we have all the right enablers in Saudi. I mean, we have perfect solar and wind resources. We have the financials, the management know-how, the technical capabilities. We have ample available land, which is always a bottleneck in a lot of economies. And this allowed us to achieve, at least to my recollection, the lowest tariffs globally when it comes to PV and wind, which is really the basis of our ambition, so to say. And even when we look at PIF, where I basically work, we have 13 priority sectors, and renewable energy is really one of those priority sectors, and where we plan to position the kingdom as not only a local but global hub for renewables and energy export. And these are not only plans. This is actually a program under execution as we speak. The kingdom has set a target to reach 50% renewables of the total energy mix by 2030. PIF has been allocated 70% of that program to execute. This program has been around for only a few years, but we're scaling up very quickly. Today, we have around 17 gigawatts, either under operation or execution, for a total capital value of around 35 billion riyals. This program is accelerating significantly, and we see that around 20 gigawatts are going to go into the system every year from now until 2030, which is a huge jump from the capacities of the past few years. The other example I want to give is also on green hydrogen. I think this is a huge opportunity that the kingdom sees, where we want to play a role not only to produce for our local demand and decarbonize Saudi, but we really want to be at the heart of decarbonizing the globe by exporting green molecules abroad. And as an example, there is a project being built as we speak in NEOM with a total value of over $8 billion. It's the largest green hydrogen project globally. It's mainly catering for export. We believe this is, although it's a large project, although it's the biggest globally, but we believe this is really just the beginning. It's the tip of the iceberg, and we think there are a lot of opportunities that we're working on to really build on that and become that global hub for green hydrogen. And then there is also what you said is the export of molecules or power. I mean, there is also the potential, I would say, to export purely renewable energy. This is a model that we haven't seen very active nowadays globally. I mean, there are a few cases that we have seen, but it's not a well-worked out model, let's put it that way. It's something that we're studying, we're looking into. I think the economics makes sense, at least on paper, even exporting from Saudi to even to Europe through long-distance transmissions. The numbers add up, but the execution is much more complex. I mean, there are G2G arrangements, there are policies you need to be aware of. So it's not easy to execute, but definitely the economics do work out. Now, when it comes to basically electrons versus molecules, I think really it will be dictated by the market. It depends where the market demand is and how things will develop. But the good thing is in Saudi, we're positioning ourselves to cater for both. I mean, we're building large capacities in renewables, large capacities in hydrogen, and we're ready for whatever opportunity comes. I think on the molecule side, hydrogen, or downstream products, ammonia, green ammonia, sustainable aviation fuel, I think this is definitely happening. The market still needs time to pick up, but that's definitely happening. But on the power export, I think there are still a few question marks, but at least from our side, from the Kingdom side and PIF, we're positioning ourselves to capture that opportunity if it comes along.
Mohammed, can I stay with you for a second and just dig into one issue that a lot of governments have now focused around, which is the supply chain, and in particular, the sort of localization of that supply chain. Could you just share a little bit around how the Kingdom is thinking about that? And then, Ricardo, I'd love to get your thoughts on that point internationally.
Yeah, I don't think this is only a Kingdom issue. I think this is a global trend that we're seeing. I mean, there are definitely benefits to localize. I mean, job contribution, GDP contribution, balance of payments, and so on and so forth. But what we've seen in the market, I mean, this localization really picked up after COVID. I mean, when COVID happened, there was a huge supply crunch in the market. I mean, all the economies were benefiting from very cheap renewable products from China. This is how it was working for the past 10, 15 years. And if you look at the manufacturing capacities, I think it's probably 95% plus is located in China. But I think there is a trend to localize these products. And when the COVID happened, there was a huge supply crunch and there were delays across the globe of renewable projects. So when that happened, it became more urgent and more important. It wasn't a question of economic development. It was a question of security of supply as well. And I think this triggered that heavy push for economies to localize. We've seen the US has the IRA incentive program. Europe have also several programs to support localization. Similarly, the Kingdom has its own program that's being led by the Ministry of Energy to localize. And I think each program is really different. Each country is developing something that's catering for their own economies and what works for them. A major issue is cost competitiveness. I mean, if you're going to localize production in your country, and I think this applies to any economy, there will be a step up in cost. Okay, I think this is something that's given. But I think there is a roadmap to bridge these gaps. Okay, and I think this is exactly how we are looking at it from PIF and KSA side. So in PIF, we recently established a company called Renewable Energy Localization Company. Its sole mandate is to localize renewable equipment in KSA. And if we really, as Saudi, want to position ourselves as a global hub for renewables, having the supply chain in the Kingdom is a major enabler. And I think this is exactly what we're focusing on. So over the past 3 months, we actually went ahead and signed 3 large-scale deals that basically form the basis for that industry or supply chain industry. We just signed an agreement, a joint venture agreement with TZE of China. for 20 gigawatts ingots and wafers, which is part of the midstream of solar. We also signed with a company called Jinko Solar for the downstream of renewables, which is cells and modules, for a total of 10 gigawatt production capacity. We've also signed with a company called Envision Energy to manufacture and localize wind turbines and nacelles and other products. Of course, these three companies are the standard in the market. They have the biggest capacities, and they're quite well known. Although these products are quite large capacities, I think it's necessary to achieve the cost reduction that comes with that, with the economies of scale. But that's not the end of it.
Mohammed, can I, if you don't mind, sorry to interrupt, but I'd love to complement what you're saying, which is very interesting, with maybe Ricardo's perspective from an international company. How do you see, I think Mohammed's point's absolutely on point around, we are seeing this trend of localization, but cost becomes an issue. I mean, how do you see international companies and investors kind of navigating that?
So let me connect the supply chain with the massive demand that we need to address. Today, clearly the scarcity has shifted to the supply. And when I say the supply, it's not only solar panels, wind turbines, batteries, but really also the lack of permitted projects. There is simply not enough renewable projects to serve that demand, the lack of transmission. So I think one of the key competitive advantages of AES was to how to really address those bottlenecks and address the supply chain issues. So first, with respect to the equipment, clearly the way we serve as AES, the US, from a supply chain perspective is totally different than the rest of our international operation. And why is that? Because you do have a tariff to everything, almost everything that comes from China. There are always some tariff issues with respect to even if you move it through Southeast Asia. So as Mohammed was mentioning, through the Inflation Reduction Act, there are incentives to reindustrialize America, and we have been working towards moving more and more parts of our supply chain to the US. Is that going to be completed in the next 5 or 10 years? No, because at the end of the day, the US is very much dependent on China, and the world dependent on China. Now, what we have seen is that if you don't move more to the US, which someone could say it's more expensive, yes, it's more expensive, but net of the tax attributes, you get more or less, to a competitive price. And the reason I'm saying this is because there are discussions about repealing the Inflation Reduction Act. If the Inflation Reduction Act were to be repealed, there's no way the US can be competitive. Just think that I pay a solar module in the US 30 cents per watt if I bring it through Southeast Asia, and 36 if I locally manufacture, including the cell, whereas in Chile I pay 11 cents per watt. So really the Inflation Reduction Act and the tax incentives are more to compensate those tariffs. But I think more importantly, what I'm trying to say is having an international portfolio, at least for AES, has allowed us to benefit from the oversupply, especially coming from China, but then also developing a local or domestic manufacturer capacity to serve the US. There is no other way to have a resilient supply chain and be able to bring all the projects on time to our customers. Time to power for a big tech or for a data center is absolutely critical. So the ability to execute and bring the projects online is critical.
And Jennifer, I think we hear quite a lot about how big countries like the Kingdom, like the US, can attract this with the programs that they roll out. What about the billion or so that I mentioned that are in energy poverty at the moment? What technologies are coming that will actually provide them with access to power?
Yeah, I mean, at the end of the day, this is, I think, where a distributed production model can start to help, right? And so that distributed production model can happen with electrons, but also with chemicals. And I think by combining those two, you can create ecosystems that are self-sustaining. in our case, we use waste resources, waste carbon, like municipal solid waste and CO2. But the whole point is these are things that are dispersed. Petroleum, as you know, is the densest liquid known to man. And so you always try to bring it to a centralized location where scale is about scaling up. And so I think what we need to start to focus on is some distributed approaches where the scale comes from building the same thing over and over and over again. So I do believe that we can transition very quickly in a distributed model. And then, of course, as a function of time, you might start to build bigger facilities that make more sense. But if you want to get something to a location quickly, start simple, start small.
And maybe, Anthony, just building on that, I mean, go on if you want to build on that yourself.
No, definitely. I think we see big demand for energy from data centers, continuing use of gas, etc. The problem is, I think you said it earlier, that the big energy, the big tech companies can simply afford it. So I think a lot of people are going to get priced out, particularly the global south. And there's going to be pinch points in the supply chain. So I think we need more, I would say we need more data so we make better decisions. And I think some of the things we're working on would really help and inform policy and action.
Well, that's fantastic. So I think we're at time, I see. So one last question to each of you in one sentence only. This panel was all about how we're securing energy for the next century. What's your boldest ambition for how we're going to power the world at the end of this century in terms of technologies? Anthony?
Well, everything's going to be green and there's going to be sustainable fuels.
Jennifer?
Everything, all of the above. You have to throw everything at this wall, even things we haven't started to scale today. And I know we were discussing nuclear. It'll be part of the equation, just like all the other types of renewable power.
Ricardo, nuclear fusion?
Yeah, so it's going to be much more electric, carbon-free, optimized by AI, no doubts that there is a role there. And I think my point is wind, solar, batteries will dominate the next 15, 20 years. Small modular reactors, I don't think the big nuclears will, there is a lot of hype, but, really it's going to be more a small modular reactor, long duration batteries. Advanced geothermal, I think it's going to play a role. So that's how the capacity, the carbon-free capacity will come.
Last sentence to you, Mohammed.
All of the above. With the demand that's happening, you will need everything that's cost competitive to get it done. And as they said, I think renewable and batteries is definitely up there, but I think we'll probably see nuclear picking up soon as well.
Great. Well, that was a fantastic panel. Ladies and gentlemen, you can join me in thanking them. Thank you very much.
Thank you.